Hello all. So today I would like to show you how you can load a Grasshopper files directly in Unity using compute.rhino3d, which is a REST API front end for a Rhino geometry core. Last time I showed you, I made a video how to load a Grasshopper file through a pure Python, but this time I'm gonna try it in Unity so that you can interactively control the geometry inside Unity using Unity's graphical user interfaces. So let's do that. So since the project made in Unity is gonna be a bit more complex than the Python ones, so I split the steps into 8 steps so that we can follow each steps one by one carefully in detail, since we're gonna write a lot of script, a lot of C# codings in Unity later on. Okay, so the first step is obviously to set up compute.rhino3d, which I've been explaining in other videos as well. So I'm just gonna show you some brief way how you can do that, then we're gonna skip this one pretty fast. Okay, in order to run compute.rhino3d, you need to have two things. One is Rhino work in progress version, and then also a compute.rhino3d front end. I'm gonna show you where you can download those. First of all, for Rhino work in progress version, you can search for rhino.rip and you'll see a web page where you can download the Rhino for Windows.rip, which is the newest version, a daily updated version, which you can only download if you have a license for Rhino 6, so be aware for that. And after you download it, you need to have one more thing, which is a compute.rhino3d front end. So I'll show you where it is. Now in a GitHub page, search for compute.rhino3d and you'll see a official GitHub page for compute.rhino3d where it explains how you can use it, how you can download it, how you can install it in this page. So if you go to this page, compute.rhino3d, click the installation guide here, and since the technology is pretty new, sometimes the way to install this compute.rhino3d changes in time. Like this one also updated like 8 days ago. So go to this page to check out how you can install this. I did make a video like April 2019, in order to how you can download it, how you can install it for Python, which you could still use it for Unity in this video, so you can also check this out if you're curious. But I think it's better you read through all these documents first, because there might be some changes how to install it. So that's how you install it, and once you have installed it, you should be able to run a compute.rhino3d server. So once you've installed it or downloaded the file, you should be able to see a list of files like these, a lot of DLLs and XS, and from that there's a file called compute.frontend.exe, so you can run this to run a compute.rhino3d front end server, and if it succeeds, you should see a command line looking like this, and you can also check if the service is running by going to the task manager. Then if you see a compute front end running, then it's successful. Let me check that again. Service, go to a service, compute right front end, and right now it says stopped, so I think I should run this. Control C to cancel it. Double click, and the server is running now right now. And in order to check if it's running, okay, it was 8081. So localhost colon 8081/version. If it shows any messages, the version of Rhino and compute.rhino3d API, then it succeeded. You are good to go with this server. Next step, obviously you need to have some kind of Grasshopper files in order to load it in Unity. So let's prepare something. You can just create your own, but there are some stuff that you have to follow, some rules in order to create a Grasshopper file that can be loaded in Unity. So I'll show you what that is. Okay, so this is the sample file that I made for this tutorial. What you can do, you can control the position of the point, and based on that position, it's making a kind of a, I don't know, tiling pattern based on the point position. You can also control the scales of the mountains on the top and the bottom. You can also control the height range. You can also control the angles, the twisting angles, and so on. Pretty Grasshopper-like geometry, I assume. Now, there are rules in order to create this kind of geometry. I mean, not much rules, but there are an important 2 rules that you have to follow in order to use it for compute.rhino3d. So I'll explain that. Okay, so first thing you have to do is which component will be your input, which component you want to replace with a input value from a Unity. So in this case, I am only allowing a primitive component, which in this case a point primitive or number or integer primitive, which is an empty box, like shown in this screenshots. And once you chose which primitive components you want to replace with Unity's input, then group them, make a group for each of them. Then you have to label them as a following term, which is capital RH underscore in colon, then any kind of input name you want to use. Maybe no space is allowed, I think. And that's the rules for the input. For the output, you can do pretty much the same things. Just create a geometry component, then connect to a final geometry that you want to show, and group it, make a group with that geometry component, then label it as a capital RH underscore out colon, then use any output name you want to use without spacing. Now, there are one things you want to mention, I want to mention about for the output, is that since we're gonna send the geometry in Unity, and Unity in default can only show meshes and as a graphic, so in this example I'm gonna limit the output only as a mesh So no B-reps, no surface, no curves, no points is allowed. I mean, if you make your own parser in Unity, how you can deal with those information geometries like points and surfaces, you can still send it. But just to make this simple, I'm only gonna send meshes in this tutorial. But you can you can just extend it by yourself in order to send any kind of geometry and use it to visualize. Okay. So let me show you an example how I made the files. It's pretty simple. You have those sliders, and these are the inputs that I want to control through Unity. So one is the point position of on the surface, which you can control in Grasshopper. You can control it in MD sliders. And one is the scales of the top part. One is the scale. Maybe this is the top part, this is the bottom part. Or the scales dependent on the position of the point, I think. And then the height ranges, which is this one, grouped by, which is a number component and named as RH_in height, and also a twist angle, which I set it as an integer here, integer component. Then as an output, I'm using geometry component and group it with and named it with RH_al geo, which is the name of the output that I'm going to use. So this is one example. I also have another examples here, which is this one, sticky ball. So in this case, it's using different types of components, but the rules applied here is the same. You group the primitive components that you want to use as an input or parameters in Unity. So in this case, the radius of the first ball, the radius of the second ball, and then the point position of the first one, the second point position, and then the radius of these arc which connects those balls. Okay, and go into the output, pretty much the same, using geometry component to group this component, then name it as RH_out and geo. I mean, this geo doesn't have to be its name, it can be any kind of name. I'm just naming it geo because it's understandable. Okay, so that's the basics, how you can make your own Grasshopper files. If you keep those rules, you can just use any kind of component, even the plugins. So try that out yourself. There are some difficulties using kangaroos because it's using kind of inner timers in a Grasshopper in order to calculate the results. So this kangaroo might not work properly, but other than that, it works perfectly. So try that out. So make your own Grasshopper file and let's go to the next step. Okay, from now on we're gonna work in Unity, so let's create a Unity project, and we also need to import some libraries in order to deal with the Rhino geometries, so let's do that first. Okay, for the Unity I am using a version Unity 2019.2, which isn't the newest, but above 2018 should do fine. If the Unity can load .NET 4.5 libraries, that will be fine, I think. Below that, like less than 2017 or version 5 wouldn't work properly, I think, because it cannot properly load .NET 4.5 libraries, which you have to use it for in order to use the Rhino libraries. So keep that in mind. Then first of all, let's import some libraries that is needed in order to deal with the Grasshopper files. So first I'm gonna make a plugin folder here. Then let's download some C# libraries, .NET libraries from a NuGet package managers website. Okay, so let's go to a NuGet gallery page where you can search for the .NET packages. And first thing you want to search for is the JSON. So we're going to use this newtonsoft.json, which is a pretty popular library in order to deal with the JSON files. So I'm just going to download the newest files here. So click download package. Also, let's search for the REST sharp library. I think the top one should do it. So this library will deal with the REST APIs, which we're gonna use it in order to send a Grasshopper file through to a compute.rhino3d server. So download this as well. I think the newest one should do fine. Download package. Right. Now next, let's download a package for a Rhino geometry, the Rhino SDKs. So search for Rhino3d in NuGet. And there you see 3 types of libraries: Rhino3d io.desktop, Rhino3d io.android, and .ios. So obviously Android and iOS for the mobile files, the mobile platforms. The desktop will work on either on Windows, Macintosh, or Linux. And I also tried it on WebGL, which you can export from Unity. So let's choose this time. Rhino3d io.desktop and download the package. Okay. Now once you've downloaded all those files, go to the download folder. Then you should see a package named as a NUPKG extension, which you might not know how to deal with those, but this is just a zip file. So you can just extract it by changing the extension name to zip from NUPKG to zip. Then it will be seen as a zip file which you can extract. Okay, so from Newton JSON files we can go to a live folder, and under a .NET 45 you should see a newtonsoft.json DLL, so extract that. For the REST sharp, under the live folder .NET 452 there's a DLL named as restsharp.dll, so extract that. And for the Rhino 3DM, under the live net 45 Rhino3d io.dll. And also for the Rhinos you also have to extract binary files for the specific platforms, which is for the Windows and Linux. So under the build folder, net45, you should see Windows 64, Windows 32, and dylib here. So each of them specifies the platform target. So the lib Rhino3d io native.dylib means that this is the library for the Macintosh. So if you want to use it on Mac, use this, extract this. If you want to use it for Windows, then choose either one, 32-bit or 64-bit. I'm going to choose 64-bit one, and this one is named as DLL, so extract that. Okay, so you have got all the DLLs that you need to import into Unity, but there is also one more DLL that you want to import it into Unity in order to read a Grasshopper archive. So let's also find that. For that one, you cannot search on NuGet Gallery webpage, but you have to go to an installation folder of Rhino 6. So under a program files, Rhino 6, you should see two folders, and under a plugins, there's a folder called Grasshopper. So open that, and there you see a DLL named as gh_io.dll. This DLL library will deal with reading Grasshopper archives like .gh files and .ghx files, and parse it. You can parse those files using this library. So let's also use this to read the Grasshopper files. Let's copy this into download folder. Okay, so now you have all those libraries that you need to import into Unity. So let's go back to Unity and select all the DLLs and dylibs here and copy into plugin folder. Okay, so the setup is pretty much done with this. Let's get into the next step. Now we're getting into coding in Unity. The first thing we're gonna do is to read a Grasshopper files in Unity using a library we have imported, which is the gh_io.dll library, which you can deal with the Grasshopper files .gh and .ghx. Okay, first of all, let's create a script folder. Then under the scripts directly, let's create a C# script named as gh_loader. Okay, and let's also create a empty game object here on the scene and a sample scene. And let's name this, I don't know, gh_loader to make it understandable, and attach a gh_loader script here. Okay, now open this gh_loader using Visual Studio or any IDEs, and let's start writing. Now, first of all, let's import some libraries that we're gonna use, which is gh_io.serialization. Also using gh_io itself. I might not use this though. Okay, let's see. Okay, let's also use using system, because we're going to use a lot of conversions. Alright, and first thing, let's have some variables here which you can change it on the inspectors. First of all, the name of the Grasshopper file, so I'm gonna name it gh file, and also a URL for the compute.rhino3d server. So I'm gonna call it service URL, and we have already checked where it is, which is where I'm running the server on local right now, so it's HTTP localhost 8081. So that's the endpoint. No, that's the address. Okay. Alright, also let's create some public private string data which holds the encoded Grasshopper file data in order to send it to a compute.rhino3d server, which is gonna be a 64 string. Alright, so we're gonna test importing or loading the Grasshopper files in void start to see if I get it really worked out, if the code really works out. So the first thing, make a class called gharchive, which holds the archive information for the loaded Grasshopper files. I'm gonna name it archive and new gh archive, and we're gonna use the function called read from files. And so we're gonna have to specify the path where you can load up the Grasshopper files. So let's think about where to upload those files, or where to locate those files. So I'm guessing placing the geometry files or Grasshopper files under streaming assets would be a good idea, because, or maybe on resources, but in this case I'm gonna set it on streaming assets so that you can easily change the path afterwards. Maybe you can download the GH files from the website or so on. So I'm gonna make a folder called streaming assets, and I'm gonna put some Grasshopper files inside this folder. Okay, so these are the files. What I showed you is this dekeyball.gh and tiling.ghx. So I'm gonna copy these files onto the streaming assets like this. Right, so I have two Grasshopper files. One is ghx, has an extension ghx, and one has extension .gh. So both one will work. Now let's go back to the code. Then I'm gonna write like application streaming assets path plus, if you're using Windows, I think you need a backslash, 2 backslashes, then plus gh file. If you're Mac, I think you just only need 1 backslash or 1 slash. Then it depends on the platform, I think. Okay, so hopefully the archive have loaded the Grasshopper file. Then after that you can read the information by accessing into a root node of the archive. So var root equals to archive root get root node. So at this point, let's check if I got it correctly. If the root gives a null, then something must be wrong. So first of all, let's check the GH loader, and I have those two parameters here. One is the file name and one is the service URL. So I have to specify the file name. So I'm gonna write tiling.ghx, which is file name for this one, tiling.ghx, under the streaming assets folder. Okay, so try running it, and if you see a message on the console saying a GHIO serialization.jchunk, then you have successfully loaded the file and also successfully printed out the root node of this file, of this Grasshopper file. So let's get into more deeper and get all the components information out of this archive Grasshopper files. So the second nest node will be a definition. So let's find the chunk named as a definition here as a GH chunk. Also under a definition, there's a list of chunks called definition objects. So find chunk definition objects as GH underscore chunk. Right. Now let's check if the object chunk is not null. If it's null, then it means nothing is inside this Grasshopper. Right. Then let's get into more deeper informations, like each of the object informations. And first of all, let's get information how many components are inside this Grasshopper files, which you can get as a integer count equal object obj is get int 32 and search for the name of object count. Right. Now let's see, let's print this out to check how many components you have here. Save it and print it out, and you can see right now I have 57 components contained in this tiling Grasshopper files. Now if I change this to a stickyball.gh and play it again, now I have 56 components, pretty close but different numbers. So I have successfully loaded the files, successfully counted the number of components. Now the next things I want to do is to search for the input groups, which I named as capital RHN, so that I can use those information to instantiate some GUIs like sliders later on. So let's do that. Right, so first of all, I am going to make a list where you can hold a list of information. One is a grid for the inputs. And also one is a name, which you have named on the label after a RH underscore in. Okay, so let's look through all the components using for loop. And first thing you want to do is to get the object information, object chunk under an object list. So use a objs find chunk. The name will be a object And since we're gonna look into one by one by using those indexes, I'm gonna use the index here as a second parameter and cast it as gh chunk. Okay. Also, let's get a container data, container chunk under a object chunk. So I equals to obj dot find chunk container as gh chunk. Now some of you might have some questions how you could find out those information, like what's the name, like how do you really know what's the name of those these specified names in order to search for the specific items that you want to have. You can easily check it out by going into a GHX file, which is a type of XML. This one, like for example tiling.ghx. .gh is just the binary files, but .ghx is the XML files which you can read it using a text editor. So if you open it in text editor, you see those markup informations written all in text. So from here you can search for how you can look at how the file is structured. So for example, this kind of object count, there is a specific chunk called object count here under a definition objects, like here. So looking these carefully, you can just pretty much extract any kind of information using those names for the chunks, name for the items, and so on. And this gh_io.dll library will make you easy to parse those XML files, which is a bit hard for us to read initial look. Okay, so after you get the container, let's also get the name of the component. The name of the component means it's the type of the component. So if it's a number component, then the name will be number. If it's a number slider component, the name will be number sliders, and so on. Okay, so name equals to container.get string and search for the name. And let's check that out again by printing it on the console. So if I play, we can have all the list of component which exist inside the Grasshopper files. Well, the group is also one of the component. I mean, it's not really a component, it may be called as an object, but all sorts of those object or component is going to be listed as here. Also has C# script as well. Okay, let's go back. Now you have successfully get all the names for all the components name. We're gonna get it. We're gonna only check the group object because that's where we have set the input, specified input named as rh_n. So if name equals to a group, then now the next thing we have to do is to first get the name of the input, which is after the rh_n colon. Then also we also have to get the type of the input, whether it's integers, whether it's a number or point in this case. So first of all, getting the name, the label of the input is pretty easy. You just have to just search for the nickname of this object, of this group object. So nickname equals to container dot get string nickname, which also contains a rh underscore in colon inside this nickname, so you might don't want that. So, and also some of the group might not contain those specified term like rh underscore in. So first of all, we have to check if the specified group has the rh underscore in term inside the label. For example, if you look at the Grasshopper files, if you go to the tiling, now this one also has a group, but this doesn't have any labels on top here. Only this group and those groups have those names with specified term rh underscore in. So in order to ignore this kind of group, we have to give a condition here. So another condition, if a nickname index of rh underscore in colon is not equal to I, then which means you found those names on the group's name. So we can continue. We're gonna create a name for the input by replacing rh underscore in with empty string. Like this, so we can remove the unnecessary string for the names, for the slider names. Okay, so also we want to get the ID of the containing objects which contain in the group. So for example, in this group currently we only got this group informations, but what we want to know is the information inside the group. So for example, we have this point component inside this group, so we want to get the type of this component, whether it's a point, whether it's a number, or whether it's an integer. And in order to do that, we from the group items here, the group container here, we can only get the GUID UID, unique ID of this component. So we have to research for this unique ID afterwards, after we get the list of ID of these components which we have to check it out. So in order to get the ID of the containing object, you can write as var item GUID equal container get GUID named as ID, and we're only gonna look at the first component. So there is a possibility that there's gonna be multiple objects containing in this group, but we're only gonna see the first object contained inside the group. So this is the index of the items inside a group. Okay, now After we get the names and the GUID of the component inside, we're gonna store it inside arrays or the list we have created before here. GUIs add input GUI item GUI. Alright. Now let's also check that by printing input name. And if I have any other printing, we're gonna have to command out. I don't think we have. Okay, so let's go back to the Unity and play. And if you see all the name of the inputs that we have set it in the tiling.ghx file, then which maybe this is not for the tiling, this is this is tiling. Okay, let's see, let's go to a Grasshopper files, and if I have, okay, currently I have 1 2 3 4 5 parameters here, and if on Unity there's 5 parameters shown here, so I have successfully got those input information, at least a name first. Now we also want to get the types of each component list contained in the group, but we only have a unique ID for the object, so using those unique IDs we have to search again for all the components which matches with this ID. So do the same for loop using the object count, and this time look for the object. Well, until here it's pretty much the same, so I'm just gonna copy this here. I'm just gonna copy these 2 lines here and paste it. And this time we're gonna search for the instance GUID, which is an instance unique ID for this specific object, which I'm running one by one on the loop. So var instance GUID equal container get GUID under a name of instance GUID as gh. I don't think I need to parse it. Okay, so, and after that we're gonna check if this instance GUID is contained inside the list we made here, input GUID, and if it matches, it means that this object that I'm looking at on the loop is the one that's contained in the group, so we can get the type of that object from with that conditions. So input GUIDs, if input GUIDs contains this instant GUID, then we can get the index number of the input GUIDs list. And from those index, we can first get the input name. From the input names list. Then also, most importantly, get the component name, which is either a number, point, or integer, by calling container get string name. So we also want to check this out by printing it. Component name. So as you can see, I have 1.3 numbers and 1 integers, which corresponds to the name of the component inside the group of the input. So point, number, 3 numbers and 1 integers. So seems correct. Alright. now here we have all the information we needed. We're gonna store it in a list, maybe a private list inside this class, inside this Unity class. But before that, we're gonna create some custom data class in order to collect all those information, like the name of the input, the name of the component, and maybe also the value of the input, which we're gonna use it later on to change it via sliders, via GUIs. So let's create a custom data called as gh input. Okay, so let's under a class, under a gh loader class, I'm gonna make a new class called gh input, and have 3 variables. One, component name, also one with the label of the input, also a value for this input. So the value could be any value, like could be float, could be integers, could be string, could be any other type. So I'm just gonna say it as an object, and value. Right. Also, let's make a constructor for this class. Gh input string component name string label. We're gonna keep the value as null as a default for default. So the label equals to underscore label, component name equals to underscore component name. Okay, so this is the class that we're gonna use to store the information we got here. So let's create a gh input equal new gh input that we have just made with a component name as well as the input label or input name. Okay, so and we also need to have a list where we can store all those collected input information. So let's go on top to create a private variables named as list a gh input gh inputs new list. Okay, and add this newly created gh input object inside the gh input list like this. Okay, now I think we're ready for the next step. We have loaded the Grasshopper files, we have loaded every information we need in order to instantiate the input sliders, input parameters. Okay, so let's go to a next step. Okay, on step 5, we're gonna create a GUIs. In this case, I'm gonna create a procedural sliders based on the information we got from the Grasshopper files. So let's do that. Okay, so since this is gonna be, we're gonna create a procedural sliders, we're gonna use a onGUI monobehavior function to write a procedural GUIs or sliders. Okay, so let's go back to the code and we create a function called void onGUI. And inside here, first of all, we're gonna look into all the information which we have stored in the GH inputs list. So make a loop, look through all the GH inputs, and get it from the loop. Okay, and we're gonna set some offset values for the layouts. I'm gonna make an integer variable called offset as 25. Maybe a width of the sliders to be like 150. Okay, now let's start. We're gonna start by creating a label for each sliders. So GUI.label and make a new rectangle. X position will be an offset, Y position will be an offset plus a 660 times I, and the width, then the height will be around 30, and the name of the label will be the name of the input list stored in the GH input label. Okay, let's check that first. Go back to Unity and play. And if you see those text on the display, succeeded. Let's change the camera skybox to solid color, maybe black, so that we can easily see. Okay, so we have 5 parameters here. If I change this to a sticky box, sticky bowl, the parameter name should change, corresponds to the file name, corresponds to the input name listed and stored in the file. Okay, looks good. Let's go back to the tiling.ghx. Okay, and next we're gonna have to create a sliders for the point number and for the integers. So let's create a switch case for a GH input component name. So case, if the GH component name is point, or if the GH input component name will be a number, or integer, or if anything else, we'll just continue. Right, and for the point, okay, we have to first check if the GH input value is null or not, because it should be null because I haven't stored any default value here. So if it's null, then we have to store some default value here. And since the point information will be 3 values, x, y, and z, I'm gonna just to make it simple, I'm just gonna set the value as the 3 lengths float array. So the GH value will be new float, the size of 3, and also let's store a default value inside each of the index inside this float value. So right, like this, and since as default GH input dot value is a object, so we have to cast it in order to deal it as a float array. So float GH input value and equals to 0. Okay, I'm missing something here. Right, so this will be a default value, so all the default value for the point will be 0, or maybe 0.5 might be better. Okay. Also do pretty much the same for the number integer for the default value. So if for the number it's much simpler, GH input value is equal to null, then since this is just a one value, I'm gonna just input value equal 0.5. Now for the default value, I'm just setting as 0.5 directly as a constant value here, but you can also search for this inside a Grasshopper file using the one we did last time on the last step by searching the Grasshopper archive using GHIO DLL, but it's gonna be more complex, so I'm gonna skip that one for this tutorial. Okay, so this is for the numbers. Do pretty much the same for the integers. Copy this and paste it here. But since the integers cannot be a float, so I'm gonna set it like 10 as a default number. Okay, and I think that's fine. So these are the default numbers, and next thing we want to do is to create the sliders after we made sure that some values are stored inside this GH input value. Okay, so for the point, we're gonna create, to make it simple for this time, we're gonna create just 3 sliders on the row on the column, so that each of the sliders corresponds to X, Y, and Z. So we're gonna make a loop, the count to 3, and the slider value, which comes from the GUI horizontal slider. We first have to set up the size of each sliders, so it's gonna be offset 40x plus. Since we're gonna array this on the horizontally, we're gonna do some procedural calculation here. Divided by 3f plus 5. Cannot see. Times n. Okay. 25 plus 30 plus 60 times I for the Y position, and width minus 10 divided by 3 divided by 3F for the X size and 30 for the Y size. Oops, did I miss something? Okay, and close the parenthesis, and also you have to set the slider position as a number, so you can directly get the numbers from the GH input value. So first I have to cast it to a float array, and GH input value, and get the n index value, and the range, I'll just set the range from 0 to 1 to make it simple. For this one as well, you can also get the slider information from the Grasshopper files using GHIO DLL, but it's gonna be a bit more complex, as I told you, so I'm gonna skip it. What's wrong with this? Okay, I think I'm missing something here. Horizontal sliders. Object rectangle. Rectangle, is it closed? I hope so. No. Yeah, it is closed. Horizontal sliders. Okay, I think something's missing. Let me pause this a little bit. Okay, I realized I have one extra parenthesis here, so yeah, this should be good. So now I think I've got the sliders written procedurally, and let's check that out by going in back to a Unity, play it. If you see, okay, I cannot see this. I do see the sliders, but the background black might not be a good idea. Okay, I'm gonna change the color to a light blue. Okay, now I cannot see it label. Okay. Okay, so now I see the sliders, 3 sliders here, which currently I cannot control, and just for the points, and I don't have for the numbers and the integers. Okay, let's make it able to control it. Now, after you make a sliders, you have to update this GH input value so that the slider will also correspond to the slider's position. The knob position will correspond to that value. So let's write that if float GH input value, is this correct? N is not equal to slider value. It's no meaning if the value is the same. it's no meaning to update the value if the value is the same. Okay, this should be equal, and I should have one more parenthesis here. Then I'm just gonna copy this, paste it here, equal to slider value. Okay, let's check that out again. If the slider moves, then you're good to continue. Now let's do the same for the number components and the integer components. Pretty much the same thing, but much easier. Okay, for the numbers, I'm gonna create another horizontal sliders here with the new rectangle. The X position will be offset, Y position will be offset plus 30 plus 60 times I, and the width and 30 for the height. Okay, and for the knob position, we're just gonna cast this GH input value as a float. So float GH input value. Okay, and the minimum maximum still the same, 0f to 1f. Okay, and the integer will be pretty much the same, so I'm just gonna copy this thing, line, paste it here, and the rectangle position should be the same. I'm just gonna change this variable here. I just have to change the casting from float to integers, and I'm gonna change the range from 0 to 100 for the integers. Okay. Now we also have to update the GNG input value for the number and sliders as we did for the point. So let's copy this thing from the point value here, and if float GH input value is not equal to SF val, then I'm just gonna copy this, paste it here, paste this here, update the GH input value to this float numbers. Okay, let's copy this line, paste it here, and if the integer input value is not equal to the one from the sliders, then update it. Okay, so let's check that out again by going back to the Unity to play. And okay, something's wrong with the angles, the integers. Let's go back. Let's see what was wrong. So, okay. So, SI value here. Okay, I think I needed to cast it here with an integer here again. Okay, let's do that. Alright, now it seems okay for every sliders. Alright, so instantiating the sliders, the GUIs, is done at this time with these. So let's go to the next step. Now the next step is pretty important, but a bit boring, because we're gonna deal with data structures in order to send to a compute.rhino3d server. So compute.rhino3d server, in order to send a data to compute.rhino3d server, we have to create a JSON format which stores all the necessary information in order to parse the Grasshopper files. So to create JSON files in Unity or in C#, it's a bit more harder than doing it in Python or in JavaScript. So we're gonna use this Newton.json library to create those necessary informations, and we're gonna serialize the class information into a JSON string so that we can easily send it into a compute.rhino3d server. So let's do that. In order to get the idea, the structure of the JSON file we have to send to a compute.rhino3d server, you can go to a web page, a forum page on the Discourse of McNeil, named as Grasshopper within compute.rhino3d, and there's some article or some comments which showed you the sample files for the JSON. What kind of JSON should you send? And this is the one. And if you look at it, it's pretty simple. First thing, you need to have an algo key with the base64 string of your GH files or GHX file, and the pointer. If you don't have any GHX files here or GH files written as a binary or the base64 string, then the pointer will be used to look for the GH files or GHX files on the internet. So you write the URL here if you don't have an algo here. And values will be the important key which you store all the input values in order to control the geometry, control the Grasshopper definitions. So currently for this one you have two parameters here, two inputs here, 1 and 2. If you only look at the 1, there are some keys that you have to have. One is the name of the parameter and the inner tree, which you store the types of the parameters you wanna input, using as an input, and also a data value here. And I have noticed that these values, keys and values here underneath, is not necessary, so we're gonna just use those two keys, param names and inner tree. And also the count to read only. Maybe we don't need these as well. And the second one is pretty much the same. So that's the basics. And in order to serialize the class information into this kind of structures, we have to create a custom data structures or data class in Unity using C#. So let's do that. Okay, go to a GH loader again, and underneath on the bottom, let's start creating some custom classes here, custom data classes here. Right, No. Okay, the first class that I want to make is the root class, root data structure, and I'm gonna name it as gh data. And what I have is first a string variable which contains a algo to store the base64 string for the gh or ghx files. Okay, also public string pointer, which will be a URL if you don't have an algo set. Okay, and a list of values which corresponds to this one. So we have to make another custom data which is called gh value later on, and something like this. Okay, and let's also create a simple constructor as well for gh data without any parameters here. Values equal new list gh value empty gh value list. Okay, so obviously the next data structure or data class we have to make is the data gh value. So let's create public class gh value, and for this one, if you look at the JSON key, you have two keys. One is param name, which is a string, and one is inner tree, which is a dictionary, with which the key will be a data tree path. So let's do that. First of all, the first one is pretty easy. Public string param name, just a string of the input. Second one, gonna make it as a dictionary of a string. String will be a key which corresponds to a data tree path, and a list of another new data class. I'm gonna call it gh inner value, and I'm gonna call this inner tree, which also corresponds to the name here. Right. Let's also make a constructor, public gh value inner tree equals to new dictionary gh value. Also, I would like to make another constructor using some parameters. So public gh value string param name and gh inner value. And for that one, I'm gonna store param name, for the inner tree, make a new dictionary, then inner tree add as a default value using the 0 as a data path to make it simple, and new list gh inner value with one inner value input. So this is used when you just want to have one value as an input with the data tree passed to be 0. If you want to have more complex, then you have to extend this a little bit more, I think. Now we are missing this gh inner value data class, so we have to make this again public class gh inner value. Now for this one, let's see what kind of variables we have to create. So the inner value corresponds to these objects. So one is type, one is data. The type will be string, data also is string. So this will be much easier. So public string type set get set public string data get set. Okay, and let's also create a constructor, public gh inner value. First one is empty. Also, let's also make another constructor with the parameters string type string data equaled data type equals type. Okay. So I think we have got all the data class here. Now we gotta try out making a JSON data JSON string using those classes to initialize. So let's try doing that using the information we already have from the Grasshopper files. So go to a void start function and let's add some lines so that we can convert all the information into a JSON. Okay, now maybe not in void start, maybe let's create some private function called void load grasshopper file, or parse to JSON. Yeah, let's call it parse to JSON. And okay, first of all, let's create a gh data as here, and gh data algo should come a base 64 string value. So let's go back to see what kind of values I have, and we have this gh archive data here, which can be converted into binary and then converted into a base 64 string. So we are going to pass this to a pass JSON here. So gh archive as input, and from that input we're gonna create a encoded data. So first we get the bytes data from the archive dot serialized binary. Then we already have a private variable called encoded data, which you want to use it for base64 strings. So to that variable encoded data equal, I'm going to use the convert function, convert class, to change the binary to base64 string. And with the option of base64 options, insert line breaks. Okay, now I'm ready to use it for the algo here. So gh data.algo, I'll just input a encoded data here. Okay, now next I'm gonna have to create a values for the gh data and values. So for the values, I would like to create it from the list of inputs we already have got, which is this one. So what we want to do, we want to convert this gh input list into a gh values list. So let's write some custom extension or custom static functions to the gh input to convert it into a list of gh datas or gh values. Okay, so let's do that. First of all, let's create a public static function, or no, maybe public function called gh value to return gh value. So this is a conversion function which converts gh input to gh value. The gh value looks like these, which have a parameter name and the inner tree, which contains those types and data on a specific path. So, and we have to change the type of the inner values because there are three types. One is point, one is numbers, one is integers. So we're gonna implement a switch, and if the component name of this gh input, in this case point, then return a new gh value and name the name of the input. The first input of the gh value should be param name, which is the parameter name, corresponds to the label of the group. So start with rhin colon plus label. Then comes a gh inner value, so let's create a new gh inner value with the parameter types and data. So the types for the point will be rhino dot geometry dot point 3d, and the way to write the point 3d in string is like this. First you have a curly parenthesis, then backslash, and you have an X, and also backslash to close it, colon, and close the parenthesis, plus a, okay, I need to get the values here. So the values will be a float array, so I'm gonna name it as array and float, cast it as a float array here, since this is an object as a default, and array 0. Okay, so do the same for the Y and Z. Copy this, paste it 2 times, and close it with curly parenthesis, curly bracket, and also, okay, I need to close it, these, and also add a plus. Okay, I think I'm missing something. Okay. Okay, think I need to add that plus here. All right. Let's see, and also close it with the parens bracket, 2 brackets. Okay. It's a bit confusing, but I think this is okay. And array day 0 will be X, array 1 will be Y, array 2 will be Z. So like this. Okay. Now this is for the point. Let's do the same for a number and integers, which will be a bit more easier to write. Case number. So in this case, we're gonna just return new gh value. Same here, lhn colon plus label, and for this one, gh value, inner value. The type will be system.double. I mean, could also be float, but in default in Grasshopper, yeah, they use double instead of float, so I'm using double here. Convert to single or convert to double, any value to string. Okay, this should be okay with this. So thing is that even if it's a number, you have to convert it into string as well. So remember that. And let's copy this. Let's do pretty much the same thing for the integers. Only difference is that you cast it into integer when you send it to a compute.rhino3d. So this will be a system.integer, the name of the class of the object, and this one to int through d2. Alright, so this should done it, and it's returning all the gh values, and I also need, I think I also need to give another case, on the default case. If none of the case is met, then just return null. Alright. Now I also want to make a new function which converts the list of GH inputs to a list of GH values. So for that one, I'm gonna create it as a static function. So public static list GH value to GH value list by inputting the list of GH input GH input list. Let's create a GH value list first, empty list. And we're gonna return this as a final result. And we're gonna look to make a for loop, look in all the inputs. Inside a GH input list. And GH value, add a GH value list, add a GH input list at the I index and convert it into a GH value using the function we have just made here. I guess there's a mop function in C# which do more easily than this one, but I'll just do the old way, classic ways. Okay, so now I have this function which I can use to convert the list of GH inputs. I can now go back here and GH values equals a GH input to GH value list GH inputs, which converts to a list of GH values. Alright. Now what else? Now we have got this two keys stored, algo and values. I think we're good to go to convert it into a JSON. So let's try that. Var JSON. We're gonna use a JSON convert function class from the Newton.json. So we're gonna have to import the library first using newtonsoft.json. Okay. Right. Now go back and call var JSON equal JSON convert and serialize object GH data. Now let's see how it goes. Print out the JSON file you have just made, and let's see, run it, and nothing happened because I didn't call it. Okay, I think I have to call it on. Oops, just quit it. Okay, so after you made this parse the JSON function, let's copy this function and paste it on the start. The bottom, that's the start. Oops. Parse to JSON. Now let's see. Oh yeah, I do need to input an archive here. Okay, let's try. Okay, null exception, object in reference to, okay, something must be wrong. Okay, seems like I have an error here that array is, one of the values in the arrays is null. I think I know why, because the default value is stored, the GH input value is stored only after on GUI here. So the JSON is only available after the GH input value is stored. And at this point, nothing is stored here because I didn't put any default value here. So I guess there's two ways. One is to change default value, set the default value when you load the GH files, or change the place to parse the JSON. But I guess it's a good idea just to set some default value when you loaded the file initially. So I guess I need to correct that a little bit. Let's see. Okay. So let's go into a GH input here, right here, and let's set some default value here. Okay, now I have to correct here, which I have to create some default input. Now it's a bit too much switch, but I think you'll get an idea. Let's create a default value for each component type by using switch. So I'm gonna make a value as null. Maybe I'm just gonna call it object. And if the component name is point break, if the name is number, break, if the integer, break, default, break. Okay, so if the point, then the value should be a 3 float. So new float 0, 0, 0. I'll set it at 0, 0, 0. Or maybe 0.5, 0.5. Well, I guess, yeah, 0.5 and 0.5 and 0.5. Okay, for the numbers, value will be 0.5. For the integer, the value will be 10, which all corresponds to the one I set on the onGUI function. And default, I'll just keep it as null. Okay, and value. Okay, how's that? Let's go back and play it. Okay, now I got some text. It's a bit too long because the algo is a base string, so cannot really see the whole thing. from the binaries. It's pretty really long string. Okay, but seems that it's working okay. So this step is done. The next step is to use this data to send it via REST API using REST-shop libraries, so that we can get a response from the compute.rhino3d as a mesh or any kind of geometry. So let's do that. Now this step will be much more interesting than the last one. This time we already got data to send, so we're gonna use that data to send to a compute.rhino3d server using a REST API. So let's see how we can do that. Okay, so we're gonna write some new function here called private void send gh data, where you use it to connect with compute.rhino3d. Okay. And I am going to create one private variable on top called private bool loaded, so that in order to control the request, the number of requests, because you don't want to make new requests while you are downloading a mesh data from the server. So while you are downloading mesh data, you want to prohibit another request being called. So I'm gonna make a boolean variable like loaded here to control that. Okay, so in the send data, I'm gonna start with if the loaded is equal to false, then you can call. And once it's been loaded, I can say that it's the file has been loaded. Then also let's create a list of a meshes where you wanna start the list of meshes that you get from the Grasshopper, the Rhino compute.rhino3d service. So list of rhino.geometry.mesh, called meshes, new list, Rhino mesh. Okay, now go back to the send.gh data. First thing, I am going to clear the value inside of meshes just to clean out. So meshes clear, and we're gonna have to use a REST-shop library in order to create a REST API. So in order to call a REST API, so using REST-shop, I think just REST-shop should be fine, probably. Go back to again to send data. Let's make a request. Var request equals to new REST request with the endpoint called Grasshopper, which is defined by the compute.rhino3d, and the method that we want to use is post. Alright, since we're gonna upload. Okay, so let's get this JSON data. So right now the parse to JSON only print out, so I'm gonna make this to return the JSON as a string. And let's delete those functions from the void start, but use it here inside the send gh data. Okay, so for a JSON equal parse to JSON. Now in this case I need to have this archive value, so let's also create a private gh archive and name the archive here and replace this with the global, and that way I can, maybe I don't have to have this parameter anymore. Alright, so parse to JSON. Now I have this JSON data. Next I have, what I should do is to make a parameter for the request for the post API. So add parameter. First of all, I need to define the type of the data, so it will be application JSON char set equal UTF-8 and the data itself will be JSON and parameter type will be request body. Okay, and request format is JSON. Right, I think that's all I need to set up in order to call the REST API, so let's try that out. I'm gonna use the try and catch function to do a REST API call. Okay, first client. Oh yeah, forgot to make a client. Okay, think I need to make a client for the REST API, so let's also do that. Where I should do that. Okay, let's go back to the private variable, the global variable here. Let's create a private variable called REST client, named as client, and I'm going to initialize it on the void start, so maybe on top. Client equals to new REST client service URL. Okay. Now let's go back to the load send gh data, then inside a try I'm gonna write up some REST API calls. So the client execute async. I'm gonna choose async, and request response rammed away, and if the response status code equal to HTTP status code okay, then we're gonna get the output data. Now the output data is, if you look at the JSON, it's pretty much the same as this structures, data structures, which I made it as a GH data class in Unity in C#. So we can directly use this GH data structures data class for deserialize this that output we're gonna get. So the way to do that, gh out, I'm gonna name it as gh out and use JSON convert the serialize object as gh data for response content. Now check it out, gh out, print out the gh out if I really got it. So I have to call this send gh data somewhere, so I'm gonna put it on the last line of the void start to test out. Now let's see, let's go back, clear this, play, and I don't seem to have any messages here, so I guess I'm missing something. Let's go back. Okay, looking at the code, I realized I did one mistake before, which is when I created the parameter for the JSON, which is down here to under the toGh value function. So here I'm returning a gh value like this, but for the point3d I am setting all the xyz to xxx, so I have to rename it to x, y, and z. Yeah, that should do the job, I hope. Now let's go back and try this out. Go back to the send gh data and under the client execute async, try getting the gh out deserialized from the response content and see if it works. Let's play it, and if you got the response same as gh data, you're good to go. Alright, let's go back. Now what you want to do from here is that the data type that you have just got is gh data, so just get the necessary geometry that you want to visualize from that gh data structures, then yeah, visualize it. In this case, in this tutorial, I'm only gonna focus on meshes, so I am going to find the geometry type which is correspond to mesh, and I'm gonna only visualize that. So before visualizing it, I already have this meshes list which can contain the Rhino geometry mesh type. So let's insert all the mesh Rhino geometry mesh type to this meshes list after I have done the REST API request. So in order to do that, I have to check all the inner values, all the geometry types from the output. So to do that, you can write like first of all, gh out corresponds to gh data, so it has key called values. So I am going to do a for each loop where each out val in values, and GH value. In each GH value, it has inner trees based on the number of data tree paths you have. So I am gonna call it as GH intervals. No, sorry. I'm gonna call another for each loop and var set in GH out val in inner tree. Okay, now the set is one item in the dictionary key value pair item, so I just want to have the values, not the keys. So var gh inner vals equals set value, and under the value you still have some list of values, because each data tree past has contained a list of items. So for each var gh inner val in gh inner vals, and this right here, finally I can check whether the value is either mesh or any other object. So in this case I am going to check if the value of the type is equal to Rhino geometry mesh. If so, then deserialize this GH inner value to a real Rhino geometry mesh class. So do the JSON convert, deserialize object Rhino dot geometry dot mesh, then GH inner val. Okay. I am missing something. GH interval. It says okay. I have to add dot data. Alright. Now after you get the meshes, you add this mesh into the meshes list as follows. Okay, now I'm ready to check if I have got all the meshes I need. After the full loop, maybe around here, print out the number of meshes, insert it to check if I got the right amount of meshes. So in the tiling examples, let's see, I have just one mesh, so it's pretty easy to check. Play it, and I got one, so seems correct. Alright, then let's go back, and next step, probably the final step, is to actually visualize the mesh geometry that you got from compute.rhino3d. So one more step to go. Okay, so the final step. So you have just got the response from compute.rhino3d server with the Rhino geometry mesh information, but you cannot directly use it on Unity. You have to convert it somehow that you can visualize it in Unity. So in step 8, we're gonna convert the Rhino geometry mesh into a Unity mesh to actually visualize it. And finally, you can interactively control the parameters inside Unity by running the game. Okay, let's do that. Okay, before we get into visualizing, let's add some conditions so that we don't have to request too much while we're getting the mesh information from the server. So what we want to do is that, first of all, I'm using the loaded variables in order to check if the file has been loaded or not. And I do want to add a function around inside the execute async, and after we have done all the checking from the responses, we want to check the number of meshes that it's inserted in the meshes list. If the mesh count is 0, then it could happen. So if that is, then I'm gonna make the loaded to false so that we can reload it again later on. Okay, I guess that's it for the necessary conditions. Now let's start writing a code to visualize the geometry. Alright, now I'm gonna make a new function called private void and update mesh. Okay, and if loaded, if the file is loaded and the meshes count is larger than 0, then we'll do a visualization. Okay, so first of all, let's create a, well, let's just let's create a prefab which you can store the the meshes that you want to visualize on. So go back to the Unity, create a empty object, game object. I'm gonna call this, I don't know, mesh object. And I also am gonna make a tag for this object. I'm gonna click add tag, click, I'm just gonna call this object and attach this object tag here. So later on I can search through a tag. Then in order to visualize the meshes, I need to have mesh renderer and mesh filter at least. And also let's, in order to visualize it, let's create some material for the meshes. So let's create some material. I'm gonna name it just samples. Any colors you want. I'm gonna set it to pink. Then place this samples to this mesh renderer. Right. And this is the template for the mesh object, and after you inserted the Unity mesh into the mesh filter, you'll be able to see some geometry like these. Alright, now I'll keep it to none as a default, and also let's make a folder called prefabs, and drag drop this mesh object here. And I'm gonna delete this one and go back to the GHLoader class. I'm gonna make a public variable called public variable called for the prefab. If you want to make it as an object, that will be a way to do, I think. You can also visualize the geometry by using like draw mesh functions. I don't know which one's better, but probably using prefab way is more flexible. So public game object, mesh prefab, mesh obj prefab, and by doing that you can export the mesh object prefab here. So drag and drop this prefab you saved in the prefabs folder to here. Okay, now go back to Unity and go back to the function update mesh. And first of all, let's search for the existing object inside a game scene, which have a tag called object. So game object, find game object with tag object. And if you find any, you want to delete it first because you want to create a new mesh from scratch. So var object and objects destroy object get component mesh filter mesh also destroy get component mesh renderer material, and also destroy the object itself. Alright, now I'm also gonna do some garbage collection here. Might not need it, but in case the memory leaks, unload unused assets. Okay, now let's look into each meshes, Rhino meshes and meshes list. Now this is the part where you want to convert this Rhino mesh to a Unity mesh. So the structure is pretty much similar, so it's not that hard to convert it. First of all, you have vertices from the Unity mesh, which you can access as mesh.vertices.to. Okay, let me include another namespace here, which is using system link. Okay, let's go back. So mesh vertices. First I want to convert it into list, then convert all to a Rhino geometry, which is a point 3D, point 3f or point vector 3f to a Unity vectors. So currently the vertices is written as each point of the vertices is written as point 3f or vector 3f. But what I want to do is to convert it into vector 3d for Unity. So I'm going to use the convert all function to convert all the items contained in this list. And in order to use this convert all function, you also need to have a converter and I have to make that as well. So let's, before getting into this, let's make a converter first, called as public static vector 3 and 0.3f to 0.3f to vector 3 Rhino geometry 0.3f pf to a new vector 3 pf x pf dot. Now the Rhino vault space uses a z up, but in Unity it's y up, so we're gonna swap the z and y here. Alright, what's this? I don't think I need this. Okay, another one, public static vector 3. So the other way, for the from the vector 3f, so vector 3f to vector 3. The names look similar, but one from Rhino, one from Unity, so it's different. Rhino 3 FPF, and just copy this. Same thing. Alright, now let's go back here. Oh, what's this? Let's go back to this. So vertices equals to a mesh dot vertices to list dot convert all, and inside a convert all I'm gonna make a new converter and I am going to export this into vector 3 and does that work? And I also need to call a static function that I made, 3f to vector 3. Okay, and finally I'm converted into array, which is used for vertices in Unity Mesh. Right. So this is for the vertices. Now let's do the similar stuff for normal direction. Okay, let's copy this all, paste it here, name this normals, and in this case it's mesh dot normals and convert it into list, convert all, and this case it's not 0.3f but it's vector 3f, and this one as well, vector 3f, and that should be fine. The number of points and number of normals should be the same. Alright, let's go back, and next we're gonna create a list of triangles. So in Rhino it's called faces, so let's create that. In Unity it's all about triangles, so you cannot deal with the quads, I think, so you have to convert it into triangles even if you're using quads in Rhino. So triangle list, integer, which is the index of the vertices. Alright, and let's do a for loop for each face in mesh faces. Now we have to check if the face is triangle or not. Could be triangle or could be quads. So either way, we have to make a condition, because for triangle you have A, B, and C, but for the quads you have A, B, and C, D. So if triangles, we're gonna add the triangle list. Triangle list, spell mistake. Triangle list, add face A. Triangle list, add face B. Triangle list, add face C. Now sometimes this is enough, sometimes not, because on in Unity, if the mesh face is flipped, then it's seen as transparent. So if you're not using like materials which can deal with double-sided, then the best way to visualize both sides, back and front side of the mesh, is to just create both sides by adding one more triangle, counting, and this time counting from backwards makes the back side like this. Now let's do the similar stuff for the quads. So let's make a triangle list which goes from ABC. Now make another triangle list for creating the other part of the quads. So that will be C, D, and A. Now same for the triangles. In order to create a backside, let's just copy all and count it from backward. Make the index from the backwards. So starting from C, B, A, and A, D, C. Alright. Now and now I think we're ready with all the information, vertices, normals, and triangles. Let's get out the loop and create a instance of the prefab. So game object, instantiate the prefab, which have mesh object prefab, and we're gonna get the mesh filter from this game object. Get component mesh filter. Oops. Mesh filter. Also get the mesh. Just mesh filter is fine. Okay. And under the mesh filter, there's a variable called mesh. So to a mesh, create a new mesh. For that, let's make a mesh here. So new mesh. For the new Unity mesh, let's set the vertices to vertices we have created. Unity mesh normals set the normals we have created, and also for the mesh triangles, set the triangles we have set, and we have to convert it into array from the list. Alright, finally call under the mesh filters mesh variable, apply, insert this Unity mesh here. Okay, and after you have added the mesh for each meshes to a game object, everything is all done after this. So you can load a new request again by setting the loaded to a false. Okay, I think we're ready, and we just have to call these update mesh and send GH data at some point, at some place, so that we can interactively control those. Now, the place where we can use send GH data is when we change the value of the sliders. So under the on GUI, where we have changed the slider value, which is under the case point, case number, and case integer, there is a condition we made whether the current GH input value is different from the sliders value, and if that's so, update the GH input value. So that's where we want to call the send GH data. So I'll do that for all point, number, and integer. Now, in order to update the meshes, we have to call this in the update function. So that's here. Okay. Now, I believe we are ready to deal with visualizing while playing the game. Now let's see. Play. And yeah, I think I'm seeing something. Let's see, let's zoom out. Yep. Yes, we did. Okay, now let's set the camera position, align with the editor. Okay, I think I need to set the clipping plane a bit more. 1000, maybe I'll zoom in a little bit more. And align with the view. Okay, looks good. I'm gonna copy the transform value here while in the playing game scenes, and exit. The camera position will be reset. So paste the copied component values here. Also set the file clipping values to 10,000. Play this again. Now I have this value. Now let's see if the value changes by changing the sliders, and yes, it worked. Awesome. So as you can see, you can just interactively control the geometry which you have made in Grasshopper in Unity while you play the game. And it's all connecting to a server, a compute.rhino server, to do this. Okay, I think it seems working. Let's try changing the Grasshopper files to if it works on the different files. So sticky ball.gh and try again. and the camera position is a bit off. Okay, yeah, I do see something, and if I change the arc radius, yeah, it is changing, it is functioning. Awesome. All right, so that's it. That's how you can load Grasshopper and update it in Unity in real time and interactively using a compute.rhino3d service. Okay, hope you got something. Hope you can use this for any of your project or anything. Hope you find this helpful. Okay, thank you. Bye.